Welcome guys, this is Chinagrass in short CD. Today we'll be discussing about circles because as when I asked most of the students from class 9, they say that circles was the most difficult chapter for them. So I hope that I should bring a chapter for you, online chapter. So let's focus on the circles. So before going to the whole chapter, we should know the basics. So go for it. So radius, we all know about radius. So obviously the distance between the center and the point on the circumference is known as radius. We are very much familiar with it, right? So a line segment. Now what is chord? This is a chord. This is a chord. Means a line segment intersecting 2 points on the circle is known as chord. What? This is a chord. Obviously, this is the radius. Got it? And a chord, when a chord passes through the center, then it is said to be what? Diameter. Got it? Means every diameter is a chord, but every chord is not a diameter. You can say it, right? These are the easily class 3, 4, 5 basics, right? So let's go for the class 9 basics. That is now, if we draw a radius from the center, suppose OA equal OA and OB. Got it? These are the two radii. Got it? So this part, this whole part is known as sector. Means the area between the two radii and the arc. Now A, if I name it as C, now ACB, this is known as arc. This is known as arc, minor arc. See the whole circle. This ACB is the minor part, right? So that's why it is known as minor arc. Minor arc. Got it? And it should be the major arc. Got it? This is the sector part. This is sector. And the angle between the two radii is known as sector angle. Got it? And thirdly, still one is left out. Is that if we draw another circle, suppose I'm not so good at drawing, so let's take a segment. Let's take a no, this is not a segment. Let's take a chord A, B. Got it? Now this area is known as minor segment. What? This area is known as minor segment because this is between the chord and the minor arc. Sector is what? Sector should be between the arc and the two radii. And segment is what? It should be between a chord and the arc, minor arc. Got it? This is the what? This is the minor segment. And this part is the major segment. This major segment. No, segment. Yeah. Major segment, and this is minor segment. Got it? Hope. And lastly, tangent is left out. Obviously, we should know about tangent. Any line passing through the circle and touching at only one point, means कोई भी सर्कल ले लीजिए आप लोग, एक लाइन ड्रॉ कीजिए ऐसे, पर ये लाइन हमेशा एक ही पॉइंट में पास मतलब टच करना चाहिए सर्कल का, समझे? सिर्फ ओनली वन पॉइंट. अगर ये 2 पॉइंट का सब टच किया तो इसको हम लोग टेंजेंट नहीं बोलते. So this line is known as tangent. tangent. T-A-N-G-E-N-T. Got it? I hope you got the basics. अभी हम लोग को ये सब क्या है? सर्कल एक डिश, वन टाइप ऑफ डिश, मतलब इंग्रेडिएंट्स का नाम पता चल गया. अभी हम लोग थ्योरम सीखेंगे, मतलब we need to gather the ingredients and then finally we need to cook it, means then we need to solve the questions, right? So let's go for the theorems now. Now for theorems you need to be clear with the triangle chapter. I hope you all are clear with triangle chapters. Got it? So our first theorem is equal chords subtends equal angles at the center. Right? This is our first theorem. That means AB is equal to CD. This is given, right? If AB and CD are the two chords of this circle, right? And suppose let's take O as the center. So if we join this radii, see, OD is the radii of this circle and OC is also the radii. And if we join this radii, see, it becomes a two triangle, right? So what we need to do, firstly, from the theorem, we get the idea there. Equal chords means AB and CD are equal and it is given. Subtends equal angles at the center means we need to prove this angle is equal to this angle. This is the simplest part of the theorem. So let's go to the proof part. So let AB and CD be the two chords, subtends equal angles, subtends angles A, O, B and C, O, D at center O respectively. Got it? So to prove, now what to prove? To prove angle AOB is equal to angle COD. So by triangle chapter we know that we can prove means we can show them these two triangles congruent, right? So let's do it. Proof. In proof part, let's do it. In triangle AOB and in an triangle COD. Here AB is equal to CD. AB is equal to CD. Now secondly, these are the radii of the same circle, right? So AO is equal to CO and BO is equal to DO. This is given. AB is equal to CD was given, right? AO and these are what? These are what? These are the radii, right? Since radii of what? Radii of the same circle. This is the particle region for this radii part, right? So what we got? We finally saw the triangle AOB is congruent to triangle COD by SSS rule. Right? Therefore, by CPCT, we get angle AOB is equal to angle AOC. I mean angle COD, right? Because these two triangles are congruent. We have proved it, right? So therefore, angle AOB is equal to angle COD. Hence proved, right? Let's go for the second one. See, it's the reverse. The second one is the reverse part of first theorem. So that's why I write it on together, right? So the chord subtends equal angles at the center are equal in length. So this time the problem is there. This AOB and COD, these angles are equal this time, right? Earlier one we need to prove these angles, right? This time these angles are given as equal, and you need to prove AB is equal to CD. Got it? Means the reverse part, right? So I hope you can proceed on. See, given part you write as it is. Got it? Now to prove. Now to prove what? AB is equal to CD. So if we can show somehow these two triangles congruent, then by simplicity we can say that AB is equal to CD, right? And hopefully this is so easy, right? In triangle AOB and triangle COD, what? AO equal to CO, BO equal to DO. Again, same reason, since they are the radii of the same circle, right? I hope you got it. Then finally, this angle is also equal. So what I will write? Angle AOB is equal to angle COD. Actually, this time it was given, right? So therefore, triangle AOB congruent to triangle COD by SAS rule, right? So therefore by CPCT, AB is equal to CD, hence proved, right? It was easy. I hope you got the two theorems. So on the basis of these two theorems, you can solve the questions from the exercise 10.3. So let's go for the questions. So actually I checked it out and I found that it was actually from exercise 10.2. So 10.2 we have two questions, right? The first one is same as theorem number 1 that I did just earlier, and second one is similar to theorem 2. The only difference in these two questions is that the diagrams are different. If you go through the questions, you will get it. They have mentioned congruent triangles. No, congruent circles, right? Congruent circles. Means in earlier proof, I did the whole proof in only one circle, right? Now, in the questions, it is given as that if two congruent, these two circles are congruent, it is given that these two circles are C1 and C2 are congruent. Then and their chord AB and CD are equal. Got it? These are the two congruent circles and AB is equal to CD. You need to prove that this angle is equal to these angles. Just similar as theorem number 1. But in theorem number 1, we did it in a single circle. Since these two triangles are congruent, means they are equal in area. Congruent triangles, congruent circles do have equal area, right? So since these two circles are congruent, so they will have equal areas. Equal areas means this radii should be equal to this radii. Then only they will have equal circles, right? That means this is equal to this ultimately given, then this is equal to this, right? Since AB is equal to CD, earlier only given only. So by SSS rule, both triangles are congruent, and by simplicity these angles are equal. Got it? Similarly, proceed the theorem second question with the help of theorem 2. But in that particular question also it was mentioned that two congruent circles are given. So I hope with the help of this diagram you can solve the second one. Okay, and stay with this continuation part of circle. I'll upload the second part soon. And if you find it really valuable, then don't forget to subscribe and like it down. Thank you.